reaction which is not in your syllabus, but I shall be doing only for your entrance exam. Okay. So first I'm going to do not for board exam, only for entrance. Okay. So if you wish to write, you write, otherwise you don't write. This is the reaction with carbon disulfide. Okay, reaction with carbon disulfide. Now, so first I am going to write the reaction with primary amine, then the secondary. So primary. Okay. So I have taken primary amine here, and this is our carbon disulfide, just like carbon dioxide, carbon disulfide. So what is going to happen? You are going to get here R, NH, S, and SH. Okay, this is called thiacarboic acid. Thiacarboic acid. All right. If there is all oxygen is there, we call it carbamic acid. Sulfur is called thios. Because of that, we are calling it thiacarboic acid. Now, this one, if I have oxidized with mercuric oxide, then from here a molecule of H2S goes out. Okay, so I get here NCS plus H2S is acidic in nature, so it reacts with mercuric oxide to give you mercuric sulfide and water. This compound is called thiocyanate. Okay, this R may be alkyl or aryl. It may be alkyl or aryl. It's a very important compound for organic reactions. Now, if you do it with excess, okay, so I write now here R NH2 excess. So in that case, what is going to happen? First, this is going to form, and this will again react with another molecule of the amine. So to give you it will give you R NH CS. Sorry, I'm feeling very bad because I have lost 15 minutes. Again, it will react to give you R NH CS NH R plus H2S. This is called thiourea. Okay, so we'll call it N prime alkyl or aryl thiourea. Okay, there NH2CO is called urea, and if you replace oxygen by sulfur, we call it thiourea. Okay, this is urea, and This is called thiourea. Please write. ঝাড়ু দিতাম, ঝাড়ু দিলেই আমাদের কত সময় লাগে, 15 মিনিট।
The IPC needs.
If you do secondary amine, then in that case, you'll get this. But you are not going to get this. Because it doesn't have any hydrogen, so it is not going to form. It's not going to form the. Here you will get NN dialkyl or aryl, NN dialkyl or diaryl thiocarbonic acid. This you can isolate. Okay. Now, if you have treated it in excess, you can stop here, or if you can treat it with excess, then here you are going to get this. This you are going to get same. You will get thiourea. So here it will be N prime, N prime, because they are two different. So it will be either tetra alkyl or aryl. Thiourea.
গুড্ডু গুড্ডু ভাত বাড়ছি, তাড়াতাড়ি নে, তুই খেলে আমি স্নানে যাব।
Again, this is also not in your syllabus. Okay, but it is important for your entrance exam. Is the oxidation of amines. Oxidation of amines. Okay. A. Oxidation of primary amines. So I'll not write one. What? See here. Try to understand. This is very interesting. Oxidation of primary amines bonded to primary carbon atoms with neutral chemophore. Give corresponding aldehydes. See, very interesting. Okay, I'll tell you why does it form like this. First, I'll write like this. Yeah. Say I have taken a R, CH2, and NH. See, this amine is primary, NH2 is there. This carbon, we know CH2 carbon is called primary carbon. Okay, and this is also primary carbon. Okay, so when you oxidize it by chemophore aqueous solution, what it will give? It will give you aldehyde. The oxidation means removal of hydrogen or addition of oxygen. So how does it happen? See here. If you have done the oxidation with this, see here, from here, two hydrogen will go and combine with oxygen to give you water. So what you are going to get here? You will get here now aldehyde. You know unsaturated aldehydes are not stable. Now water is there. Water hydrolyzes. See how does it do? This I have already showed you in earlier question. See here. Oxygen comes because valence of oxygen is 2. So what do you get now here? You get aldehyde to the liberation of ammonia. Okay. So this is our mechanism. You get now here aldehyde. Finished?
Yes, sir.
Okay. So let me do now one specific molecule. So in this case, let me remove. Now you know. Say you have taken here ethylamine. What you will get now? Here CH3 will be there. You will get here now acetaldehyde. I don't know why these reactions are not being included in your textbook. See here. Here, this is a secondary carbonate. Only one H is there. And the amine is primary. So in that case, you get this. How does it happen? Oxidation is being done. So what you get now here? You get this. See? So this is a ketimine. Imine of ketone. Ketimine. Now it reacts with water, okay, to give you acetone or ketone along with the solution of ammonia. So this is the mechanism. Because till now in every chapter we have always discussed about the oxidation reaction, but in this case we did not discuss oxidation. So this we should know. এরকম বলছে কম্পিউটার আমি কনসিডার করি কোনো জিনিসই বেশি ঠিক না।
আমি বলছি যে ভাত নাই
Finished?
এক হাতে নেই পাবেন ভাত আর খাওয়া তো রাত্রিবেলা ওই জন্য হচ্ছে কেন তুই জানবো মুঠে মুঠে খাস আর রোজ জানতে লাগবে চিন্তা করতে লাগে না
Okay. Now, which I'm going to do here, this is frequently being asked in entrance exam. Oxidation of primary amine bonded to tertiary carbon atoms. Tertiary carbon atoms give corresponding nitroalkenes. See here. Now, this carbon does not have any hydrogen. So it is not that one hydrogen from here will go, another hydrogen will go, you get a carbon nitrogen double bond. It's not possible. Okay? So when the carbon does not have any hydrogen, then CH4 oxidizes only the nitrogen. Okay? So what you are going to get?
আমি যদি সামনে চলে যাই এই ভাতটা ফ্রিজে ঢুকে দেবো
See this. So what you are going to get? You get here NO2 here plus H2O. You get this. Today, are you having class at in the school?
Yes,
Hello? Huh? Online classes are there on school today?
आज टेस्ट আছে মামা নতাত
Oh, okay. All right. From tomorrow onwards, classes will be. I'll not lose any time. Okay. Now we will do secondary amines. Finished. It seems today you are writing very slowly. Okay, what is the name of this one? See here, this is main molecule is propane. You have methyl on second carbon and nitro on the second carbon. So alphabetically, what should I write? 2 methyl 2 nitro propane. 2 methyl 2 nitro propane. And what is the name of this? It is 2-methyl propan 2-amine. Oxidation of secondary amines. Oxidation of secondary amines with camenophore give corresponding tetra alkyl hydrazine. Tetraalkyl hydrazine. I'll show you what is the hydrazine. Hydrazine, you know, NH2, NH2 is called hydrazine. Suppose I have taken here this dimethyl. Amine. There, huh? See, when I oxidize this one with camenophore, what do I get? See, this is called hydrazine that you know we have done in earlier chapter. Hydrazine. So what you are going to have? CH3, 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 CH3 here. I've taken two. So two hydrogen from here and one oxygen from camenophore combines to give you water. Okay. And what do you get here? We get here N, 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 N. Tetra methyl hydrazine. Please remember, this tetramethyl hydrazine is used as a rocket fuel. Hydrogen is a strong oxidizing agent. So, all oxidizing agent, thing which can get oxidized very easily are nothing but the fuel. All the fuel that you are using, whether it's LPG, CNG, then the liquid fuel like petrol, kerosene, okay? All of them that get oxidized easily, okay? So, hydrogen is a strong reducing agent. Reducing agent means what? Which get oxidized. So, it is used in rocket fuel.
Done, sir.
Yes, done, na? Okay, now see. This is A. B. Oxidation of secondary amine with peroxo mono sulfuric acid. Don't get nervous by this name. Peroxymonosulfuric acid. This is also known as Carrow's acid. Okay, don't get scared. Huh? What is the formula? H2SO5. How does it look like? Nothing I'll keep secret from you. I told you, whatever chemistry I have learned in my life, I'm going to teach. See, this is a peroxide. It's a very strong oxidizing agent. Yeah. Give corresponding hydroxylamine. Hydroxylamine. Okay, so now what we are going to get here? See. And H. Okay. So it is H2SO5. See, peroxide always gives oxygen. So one of the oxygen will come in between nitrogen and hydrogen. Okay. So what we'll get now here? CH3 and CH3OH plus H2SO5. You get sulfuric. All right. This is called hydroxylamine. That we have learned where? We have learned in aldehyde ketone chapter. First, I will write the name. It's called N dimethyl hydroxyl amine. Okay, plus H2SO4. So, click. Done, na? Okay. Now, right, oxidation of tertiary amines. Oxidation of, please remember, tertiary amine does not have any hydrogen. Oxidation of tertiary amines with hydrogen peroxide or Carrow's acid means what? H2SO5. Give corresponding amino oxides. Okay? So I'll write like this. R. So this is tertiary. See here. It doesn't have any hydrogen. So when you do the reaction with hydrogen peroxide, one of the oxygen will come here. You get this. Okay. See, this is valence of oxygen is 2, nitrogen is 3. So nitrogen is become 4. I'll put positive, and 1 is not satisfied. Okay. This is called amino oxides. Okay, amino oxides. So you can write here H2O2 or H2SO5. If you take H2O2, what will you get now? You will get water. Or if you have used H2SO5, you get this amino oxides. Amino oxides. Okay. So now we'll write the next one. These are all we have done with alkynes. Okay. Four. Oxidation of
Done.
primary aromatic amines. Aromatic primary amines easily get oxidized. To form a dark substance. For example, aniline gets oxidized to 1,4 benzoquinone. with acidic camphor. Okay, so let me write here. Yes, you get this. This is 1, 4. See, 1, 2, 3, 4. So it is 1, 4 benzo. This is a classical name. Benzoquinone is a classical name. I thought I should do because for your entrance exam, and you cannot learn against. You should learn together.
Done, sir.
Okay. Now, the thing which I am going to do, this is also your out of syllabus. Is that reaction with metal ions is very interesting. Organic is reacting with metal ions. See, that we will do separately. A chapter is there. It's called coordination chemistry. I think Drishti in advanced school, I think they have done. Drishti, you have done, na? Coordination chemistry. Hello.
Mama.
She any problem, ask her. She knows. And if she cannot reply, then you inform me. I'll take care of her. Amines. We will write in bracket primary, secondary, and tertiary. Combined with various metal ions to form different coordination compounds. Or this one also we call it as complexes. Different coordination compounds or complexes. Okay. Say you have taken here methylamine. Any, you can take methylamine, ethylamine, any amine. Okay? And you have taken a silver salt, silver chloride, silver bromide, silver nitrate, anything you can take. Silver ion. So what is going to happen now? You'll find is going to form a complex. You know by this time that silver chloride is insoluble. Okay. But if you add the methylamine, immediately the white precipitate will disappear. Why? Because it is going to form a complex. Okay. So what should I write now here? Okay, I'll write silver chloride. Let me make your life a little easy. So you'll get here. What is the name of this one? We call it dimethyl. Sorry, not dimethyl. Two are there, na? So I'll have to write here bis. Bis. Bis means two. Methyl amine. I'll put inside bracket. Silver. Within bracket, I'll put 1. And then I'll give a gap. Then I'll write here. Ajay Drishti, why do you put 1 inside bracket? What is this 1 stands for? Hello? Drishti?
It
Huh?
stands for the oxidation state of the metal.
Very good, huh? Okay. Now, if I add methylamine to copper sulfate solution is pale blue. Moment I use methylamine, ethylamine, okay, or even a secondary amine also, no problem. Then you'll find the solution will become deep blue, just like the ink. Sometimes people also say inky blue. Okay? I do not want to use this inky, all these things. Okay? So now, suppose I have taken here copper sulfate, pale blue. Okay? To that I have used added excess of methylamine. So it will give me, see, this is soluble, not like silver chloride. All right. Insoluble white precipitate. Okay? And here I will write soluble. So if I add it here, so what I will get here? Copper, CH3, okay? So this is called tetrakis. See here spelling. 1 S is missing. You don't think that normal kiss. It's tetrakis. Tetrakis methyl amine. Copper, here the oxidation state of copper is 2. Okay, then I'll give a gas. From here to here, one word. Sulfate. Okay, this is deep blue. If from hundreds of complexes with different types of metal, both should not both. Primary amine, secondary and tertiary, all of them they form this type of complexes. So these are the some extra thing which I brought you today.
Done, sir.
Okay. So now we'll again go back to our syllabus. So what we will do now? All the things that we have written now, put inside a big box so that you know that this is not in your school syllabus. This is only for your entrance exam. So it is up to you if you want to learn or not. Is optional. Is it that all of you are going to appear entrance exam, or some of you don't like to appear? Entrance exam is necessary. Okay, now we'll go for electrophilic substitution of aromatic ends. So now we'll write. I don't know, I forgot this, all the equation number and all this thing you put. We'll write now. Amino, what is amino? Amine group is a strong electron donating group, and it activates both ortho and para. First you understand, then you write. I told you, no, it's not a handwriting class. And it activates both ortho and para positions by resonance. What should I call it? R plus R. And so electrophilic substitutions occur at both the positions. I'll show you now the resonance structure. Resonance structure, so by this time you know how to draw it. See, this is a lone pair. What will happen now? Will undergo delocalization. What is the meaning of delocalization? When the electrons move from one place to another. If it is there in alkyl amines, this electron cannot move, so they are localized. See how it has increased the density of electron at ortho position. Now it will move. It will come here. So you get this. See, now it has come to para position. This it has again come to ortho position, and finally the journey ends here. So In this case, continuously this is going to happen. Resonance is not one-time affair, dear. It is an all-time affair. So it has come here. So let me draw its hybrid structure. Hybrid structure is this. See here, electron density is very less. Okay, I should not put like this. I am also hopeless. So this is the way the electron is moving inside. See here, del minus, and del minus. See, because of that, what do you write? And it activates. So these are the activation point. Activates both ortho and para positions by resonance. And when this electron is being pushed inside, we call it plus R effect. If it is being withdrawn, we call it minus R effect. And so electrophilic substitutions occur at both the positions. Santho, understood? Hello. I am using multiple language so that you can answer. Hello. Garo, I don't know. Could you understand or not? What is Garo you call? Masito or something like that? Hey, Hanania.
Yes, sir.
What do you call in Garo? Could you understand? Huh? Hello. In Garo language, what do you say? Could you understand? What happened?
Sir, naama si Jokma.
Huh?
Naama si Jokma.
Arey baapre, tell little loudly, na?
Sir,
Na?
si
Huh?
Jokma. Naama si Jokma.
I cannot understand anything. Achha, anyway. Right.
এত বেশি ময়লা হয়ে যায়
Good. Now we will do examples of electrophilic substitution reactions. Hello. Hello.
হ্যালো গুড মর্নিং শুভ রামালয়া ভেরি গুড
Okay. So now we'll do first one. We'll do here bromination. Please, dear, remember, if we want to do bromination and chlorination on aromatic system, we always require some catalyst. We call them as halogen carrier. We use anhydrous ferric chloride or aluminum chloride for chlorination. We use anhydrous ferric bromide or aluminum chloride or aluminum bromide. But in case of aniline, the nitrogen lone pair has activated this ortho and para position to such extent that you do not require any Lewis acid catalyst. Okay. So we'll write here now. Bromination of, you can do chlorination also. As I'm going for bromination, so I did not write here chlorination. Bromination of amine occurs in absence of any catalyst. So sometimes we call it halogen carrier. Okay. Any catalyst. Okay. At room temperature to form 2,4,6 try bromo NB. Okay, within bracket I'll write it proves the activation of NH2 group of aniline towards electrophilic substitution reaction. See, sometimes question is being asked in CBSE. How can you prove that amino group of aniline is a strong activating agent? So you simply write this one, that electrophilic substitution reaction of amines occur in absence of any catalyst. So it proves that amino group is a strong activating group. Okay, so this I have written for CBSE student. I don't know, and most of such question will be asked or not. Huh? Okay, so NH2 plus 3Br2. Okay, we go for bromine water, or you can do in non-polar solvent also. But water is reaction is very fast. Polar medium. So you get here this NH2 Br plus 3HBr. So you get here this name I will not write, you write this one. If you write once or twice, then you will not forget. So this is you write this here. Then below that you write white compound.
Done, sir.
Okay, now we'll go for nitration. Huh? Can I take 15 minutes more? Is it, will it create some problem? Hello? It is up to you only, because today I've
We
started.
have
Can I continue 15 more minutes? Or you have class?
So we have
class.
class.
What time? 9 o'clock?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Okay, then I'll do it in some other day. Okay? Sorry, today I have misused. Then my 15 minutes gone for my own work.